Okay, welcome back to the course MLOps from scratch. So in this session, what we're going to do is we're going to be writing our machine learning script that trains our threat detector model. Okay, so the threat detector model is what we prepared its data in the previous session when we were splitting our data into training set and test set. What we're going to do in this lesson, we are going to be writing our machine learning script that trains our threat detector model. Okay, so I took the liberty of setting up a setup.txt file. This setup.txt file contains all the instructions that are going to be necessary for us to build our machine learning model that trains our threat detector model. Okay, so now the first thing that we need to do is just as a recap, we're going to train a binary classifier to detect safe and dangerous terminal commands, and we're going to log everything on the artifacts using MLflow. The next thing we're going to do is, the first thing we're going to do from there is we're going to install MLflow. And then after that, we will create our MLflow setup script, run MLflow UI, create. This is the part right here. This part right here, that's where we are going to build our machine learning model that will train our threat detector model. Okay, and then the next thing, we're gonna start up MLflow, log metrics in MLflow, and then run the script. Okay, then we're not done. The next thing we will do is we'll open MLflow UI in the browser. MLflow server is running on localhost port 5000. Okay, and then after that, we're going to summarize out the outcome. So we're going to check model accuracy. We're going to observe the artifacts that have been logged to MLflow. Then the next phase after that, which is next week, it will be model 3.4, where we are going to deploy the model that we've trained and serve our model as an API. That's when we're going to be talking about things like Docker containers, so on and so forth. Okay, so the thing that we're going to do now is open up VS Code. Okay, let's open up VS Code. As you can see, this is our project. Let's activate our let's activate our virtual environment. Okay, so type ls cd mlops env script activate. So now that our virtual environment is activated, let's just clear that one directory below. Okay, so now we are in our project structure. Okay, in our project folder. So what I want us to do is, before we actually install MLflow, open up your browser, right? Open up your browser, type what is MLflow, hit enter. Okay, so let's read up on this. So MLflow is an open source platform. Okay, so MLflow is an open source platform that manages the entire machine learning lifecycle. That's the whole point of this course, MLOps from scratch, to take you step by step for you to become a pro, from experiment tracking to model deployment and management. Okay, so it says it helps data scientists and teams streamline their workflows, ensuring transparency, reproducibility, and collaboration. Okay, so we can even go to the MLflow website. Okay, hit that. So this is the MLflow website. You want to read more about it. So you see on the MLflow, this is what they say. So MLflow is a versatile, expandable open source platform for managing workflows, and artifacts across the machine learning lifecycle. It has built-in integrations with many popular ML libraries, but can be used with any library, algorithm, or deployment tool. It is designed to be extensible, so you can write plugins to support new workflows, libraries, and tools, so on and so forth. So listen, you have to read up on these topics. So make sure to go through this website and see the latest releases of MLflow, how to integrate MLflow APIs, and so on and so forth, how to do experiments, so on and so forth, how to use Java, Python, REST APIs, and so forth. Okay, so let's go back to the course now. So now that our MLOps virtual environment is activated, the first thing that we're going to do, let's go back. So in this session also, what I did is I took the liberty of creating a setup.txt file. So what you're looking at is a setup.txt file. This takes us step by step of what we're going to do. Okay, so the first thing that we must do is we must install MLflow. So go back to VS Code, pip install MLflow, hit enter. Okay, give it a second. Okay, excellent. So now MLflow is being installed successfully. It's been downloaded and installed. Okay, so let's say MLflow, let's test that version, hit enter. Okay, 1 second. I just want to test this. Okay, there we go. So MLflow, we're running version 3.1.0. So MLflow has been successfully downloaded and installed. So now what we're gonna do right now, let's go back, open up that setup.txt file. Okay, so the first thing that we want to do, we want to create the MLflow setup script. This MLflow setup script, so basically we're building this in modular form. We're going to build the train.py file, which will be responsible for training our threat detector model. And this section of the course, what we're gonna do here is we're gonna be writing our MLflow setup script. This setup script will be used in conjunction with our train.py script. Okay, so let's do that. Let's go back to VS Code, open up VS Code. So you remember this folder structure, right? So let me just collapse that. So our project is called Threat Detector. So this is where we put our source code. So right click, new file. Okay, so MLflow, we'll call it MLflow setup.py. Hit enter. So here we're gonna write our MLflow setup script. This MLflow setup script is gonna be used in conjunction with our train.py file, which we are yet to write. Okay, so go back to setup.txt file, open it up. Okay, so create source MLflow setup.py, and then we're gonna define init MLflow to configure MLflow experiment and URI. So here we are basically writing a helper function. This helper function is gonna be used in conjunction with our train.py file. Okay, so go back to VS Code. Let's do our imports as we did the last time in module 3.2. Okay, imports. Okay, so import MLflow, a tab. So what we're gonna do now, we're gonna define that helper function. Define helper function. Here we go. Init MLflow. So what I'm doing right now is this function doesn't do anything yet. Okay, so that's why I put the keyword pass there. That means that the function doesn't do anything yet. Basically all that it does, it just returns void. Okay, so what we're going to do is we're going to pass in arguments inside this function. So the first argument that we're going to pass is the experiment name. So this is the name of our experiment. Experiment name, it's a string. So threat detector, and then the next argument that we're gonna pass is our tracking. The next argument we're gonna pass is tracking URI. So this right here is our universal resource identifier. So because sometimes the reason why we're not using the word URL is because URL has protocol in there. So uniform your resource identifier is general. Okay, because sometimes you may have protocol in there, sometimes you may have a path where your ML models are actually are. Okay, so this will define where the MLflow server will be. Okay, so in here it's going to be running on localhost on port 5000. Okay, so now what we have, let me just expand this a little bit so you can see. Okay, so this is our function. So what we want to do, we want to define the body of the function now. So this is a helper function that is going to be used in conjunction with our train.py file. We haven't yet written that yet. So okay, so the first thing that we want to do is we want to call MLflow and set experiment. Okay, in here we're going to pass the experiment name, which is that, and then MLflow set tracking URI, and then here we're gonna pass tracking URI. Okay, like so. Okay, so now that we have this, this informs us also. Okay, so when MLflow initializes, this is what it will do. Okay, it will set the experiment name and the tracking URI. Okay, so we can actually just do a print two print statements here. Another one, let's use f strings and say experiment name. The name of, so if you don't set the name of the experiments, the name of the experiment, MLflow will set it by default for you. Okay, so let's say experiment name. There we go. Okay, come on, stay with us, man, stay with us. Okay, tracking URI. Here we go. And that's our tracking URI. All right. Okay, I hit that quickly. Hit tab. There we go. So this is what we now have now. Okay, we've defined our helper function. This helper function, what it does is, all that it does simply, it's basically initializes the name of our experiment, and also where, oh wait a minute, HTTP. There we go. Okay, so we've got our experiment name, which is Threat Detector. We've got our tracking URI, which is found on localhost port 5000. Okay, and then what we've done, let me just separate these two. So we've set the experiment name, and then also we've set the tracking URI. So here basically what it does, it just prints the name of the experiment to the terminal. Not only that, but also it prints out the server name. Okay, okay, so print, let's just say MLflow initialized. Okay, so this will be the experiment name. This is the tracking URI. So in this case, now we are done setting up our helper function. This helper function, we're gonna call it in our train.py file. Go back to the setup.txt file, open it up. So the next thing that we want to do, right, we want to basically run MLflow UI. This MLflow UI, that's where you're going to see your metrics, the performance of our model, the accuracy of the performance of our model, so on and so forth. So go back to VS Code, open up VS Code. Let's open up a new terminal. Okay, so just click this arrow. Okay, and then create another terminal. Let me just activate cd MLOps env script activate. So what we're gonna do here, we're gonna initialize our MLflow UI. So type MLflow UI and hit enter. Okay, here we go. Okay, so you see that thing right there. Let me just raise this up so you can see properly. So what you're looking at here now, the MLflow server, it's up and running. Okay, it's waiting for connections, it's waiting for requests. Okay, so it's running on localhost port 5000. So when you highlight this, you can actually click it, it will open in the browser. So what you're looking at here is the MLflow initialized. Okay, so this, what you're seeing, this is the MLflow dashboard on the browser. Okay, so let's open up our setup.txt file once more again. Okay, so this is what we've done. So step number 3 is done. So let's just mark these like we've done the last time. Done. Okay, this also is done. This also has been done also. So now this is the meat. Now this part right here, this is where we are going to write our train.py file. This Python file is a machine learning script that we're going to use to train our threat detector model. Okay, so let's go back to our VS Code now inside our project folder. Okay, let me just do that. This is our project folder. So go to the source directory and right click and say new file. Okay, so here we're going to say train.py. Hit enter. So in this file right here, this is where now we're going to be using our pandas library. our sklearn library for training our model and selecting the model or the type of model that we're gonna be using in this course. Okay, so go back to the setup.txt file. Okay, this is now stage number 4. So in this stage, we create the model for training the script. We're going to import libraries, pandas, sklearn, MLflow, and so forth. We're going to initialize MLflow, which is that helper function that we created earlier. We're going to load our training set, okay, using pandas. And not only that, but we're going to split the command and label columns, which is in our training set, into X train and Y train. Okay, this is our training set. As you can remember, if you go back inside data folder, open that up, this is what we're going to be using when we write our train.py file. Okay, let's go back to our setup.txt file. Okay, where were we at? Okay, here we go. So then the next thing we're going to do after we split our training set into our command and label columns, we're going to vectorize the commands with our CountVectorizer, which basically what this means, vectorize commands with CountVectorizer means this: we're going to convert our raw terminal commands like ls, which is to list directories, rm, which is to drop a directory or remove a file, into numerical feature vectors that the model can process or understand. Because the thing is, machine learning models don't understand text labels like that. You understand? So that's why we have to vectorize it. It understands numbers. Okay, that's why in our column vector, in our column Y train, we've got numbers 0 and 1. 0 to say this is a benign command, and 1, this is a dangerous command. Okay, then the next thing we're gonna do, we're gonna feed the model. The name of the model we're gonna be using Logistic Regression to the training data. Okay, so let's go back to VS Code. All right, clear that. So now let's go back to our file now. Now that we're here, we need to do our imports as normal. Okay. Imports. Let me just go back to our MLflow setup here and just keep the consistency. Okay, here we go. Let's go back to train.py file. Okay, so these imports that we're gonna do here, they speak to this. Let's go to our setup.txt file. They speak to this. We're going to be importing these libraries right here. We're going to import pandas, sklearn, MLflow, and so forth. Let's go back. Okay, so let's begin. Import pandas spd from sklearn feature extraction dot text import CountVectorizer. So this CountVectorizer is what converts our feature matrix, which is where our features are sitting, into numerical values that the model will understand. Okay, so the next library that we're gonna import is still gonna be from sklearn matrix, import accuracy. This speaks to the accuracy of our model. Okay, the next library that we're gonna import, sklearn linear model, import logistic regression. That's the one we want. Let's import MLflow, which is what we're gonna be using. Import sklearn MLflow sklearn. So basically what this means is that sklearn model, we want them to be logged on MLflow. So this right here is sklearn. The sklearn model will be registered on MLflow for logging. Okay, so the next thing we're gonna do, from source, MLflow setup, you see that thing right there, from source, this is the directory, and then inside this directory we want this guy. This is the module we want to use. Okay, MLflow setup, import init MLflow. So this right here is that helper function that we created, which is this guy right here. So from source, import this module, and inside this module we want to use this function. Okay, so let's go back to train.py file, save that. Okay, so what we got, let's go back. So what did we do? Basically what we done is we imported our libraries. That's the thing that we've done. So let's mark that as done. The next thing we're gonna do, we're gonna initialize MLflow. Go back to VS Code. Okay, let me just slow down because it looks like I'm rushing. Okay, the next thing that we want to do now is initialize MLflow. Okay, go back to the setup.txt file. So we're going to initialize MLflow. Let's go back to VS Code. So inside here we're going to be calling this guy MLflow. That's when that helper function gets called right here. So this helper function, we're calling it from here. So the reason why I'm separating the concerns is so that you can, that's the whole point of MLOps. You get, we do separation of concerns so that the source folder contains all our scripts that we're writing. The data folder contains all the data that we're working with, which we have split into training and test set. Okay, so let's go back to the setup.txt file and see the next thing that we're gonna do. The next thing that we're gonna do is load our training.csv using pandas. Okay, let's go back. Open up VS Code. Okay, so we're gonna load our training set. Okay, this is train.csv. Okay, so go back to setup.txt file. So we're gonna be loading our train.csv file. So let's go back now. Okay, so in here we want to say train no, okay, let me just go back 1 second. Okay, so now that we've done this, we've initialized MLflow. Now we want to load our data. Okay, so go back, loading our data. So our data is sitting in data processed train.csv. So that's our data right there. Data set. So pd.readCSV. Okay, let's do that. Data processed train.csv. Okay, so this is our data now. We're going to be loading this data. So what we want to do is, let's go back to the setup.txt file. The next thing we want to do is this right here. We want to split the command and label columns into xtrain and ytrain. Okay, and this will be taken from our train.csv file. So say xtrain, this is the variable we want, put it there, and say data set, and okay, command ytrain, same thing, data set. Okay, label. So these are the columns in our feature vector, or feature matrix rather. Okay, so let's go back to our train.txt, our setup.txt file. So what we've done is we've split the command and label columns into xtrain and ytrain. This basic, what you're looking at here, this right here is this. Go to our train.csv file. You see we've got the command, and the command column is got shutdown, echo, hello, delete important.txt, and rm command, which is to drop the entire directory or folder. So now, as you notice here, under the command column we've got text data, and under the label column we've got numerical data. The numerical data will be well understood by the model, but the command data will not be well understood by the model, which is why we need to vectorize this. Okay, so let's go back to our train.py file. So the next thing that we want to do is let's go back to our setup.txt file. So okay, so where we at? We are here now. So vectorize commands with CountVectorizer. Okay, so that mean what this means is that we're gonna convert raw terminal commands like ls, rm, and so forth, like as you have it here. So train.csv. So these will be vectorized. They will be converted into numbers. It will be a matrix of numbers that represents these commands in this column. Okay, so let's go back. Setup.txt file. So we're gonna be doing this right here. Okay, go back to VS Code, train.py. Okay, so let's put a comment there so we understand where we are. Vectorize commands with CountVectorizer. Let's go back. Vectorize commands with CountVectorizer. This is a function, okay, from sklearn. Okay, so the thing that we're gonna do now is we need to do that. Okay, so what we have got this. Now let's begin to write the code for that. Okay, let's do that thing. Okay, so here's what we're gonna do. Let's create a variable called vectorizer. Count.vectorizer, let's call it up here. That's it right there. See that function? Yes, we're gonna be using it down here. Okay, so xtrain vector vectorizer fit. So this function right here, what it does is it's what's going to convert our commands. Basically, to vectorize means convert. In simple terms, we're going to be converting the text data into numerical data so that the model can understand it. Okay, and then we need to pass our xtrain data up in here. So that's what we're gonna do. So this, what we'll do, it would have converted this data right here that you see under the command column. So these are called basically these are called features. Okay, features of our data. Okay, so this is the features of our data set. So let's go back. So we've got xtrain. This is the variable that we are using. So what you are looking at here now, this function, this line of code, what it does, it basically vectorizes our command column. Okay, which is what we set out to achieve. What we've done is we've vectorized the commands using the CountVectorizer, which is this right here, and then we pass the data that we want to vectorize. Okay, the next thing that we want to do is fit the model, which is this regression model, to the training data. Okay, so open it up, VS Code. Let me just follow along with the comments here. Fit the model. Okay, we're gonna fit the model to the data. Fit the model to the data. Okay, so here's what we're gonna do now. Let's create a variable called model and assign it to the actual model. That's it. Okay, so here we are fitting the model to the data. So the next thing we want to do now, we want to initialize MLflow. Okay, we want to initialize MLflow. So let's go back to our setup.txt file. So okay, let's do a recap. Okay, we've imported our libraries, which is what you are seeing here. Our libraries have been imported, some good stuff. Okay, and then we've initialized MLflow, which is what we've done here. Okay, and the next thing we did was to load our train.csv file. Okay, this is our training data. So that's what we did, which is this line of code right here. So load training set, and then we split the training set into those two columns, which is the command column and the label column. Okay, go back to setup.txt file, and then the next thing we did was to vectorize our column data, our command column data. Okay, and then which is what we've done right here, this right here. We've done this. Then the next thing we did was to fit the model to the data. Okay, so let's see the next instruction that we must do. Let me just mark these as done. Okay, this has been done. Okay, done over here. done. Happy Friday, man. Happy done. Yeah, happy Friday, man. Beautiful day. Okay, done. So the next thing we must do, we must start up MLflow. We must do this. We now need to start up MLflow, okay, in code wise. So what we've done is, let's go back to this right here. The MLflow server is running, is expecting requests, okay. So go back to this terminal right here. Open setup.txt file. We must start up MLflow. So let's go back and put the comments up in there. Start up MLflow. Okay. With MLflow, start run. So this right here will start MLflow. Okay, it's gonna start up the MLflow instance. Yes, we've started up, we've ran MLflow UI. The MLflow UI command, what it does is it start up the MLflow UI on the browser. Okay, so go back to setup.txt file. Start up MLflow. So we're gonna train the model using the training data. Okay, so right here, basically we are just assigning here. I just want to make mention of this. Here we are simply just assigning the logistic regression model to a variable, okay, called model. So in the code here, fit the model to the data. Let me just say this. Okay, let's put it this way. Let's make it more clear. Assign model to variable, okay, which is what we've done here. Okay, so the next thing that we're gonna do now we need to do this. We need to train the model using the training data which we vectorized. Part of the data needed to be vectorized. We've done that. So now we need to run this. Okay, MLflow. The thing that we want to do, model.fit, and then in here we are going to pass this variable right here. This variable contains the data that has been vectorized, which comes from this column right here, this command column that has been vectorized. Okay, so what we're going to pass in here, we're going to pass that. So xtrain, which is that, and also ytrain. So this right here, remember now, the ytrain is this part right, is the label, okay, which there was no need for us to vectorize the label because they are in numerical form, which is what we want. This we did because it's not in numerical form, which is what we had to convert during using the vectorizer. So now that we've done that, let's go back to our setup.txt file. We need to make predictions on the model. Okay, so let's go back. Let's create a variable called predictions and assign it model.predict, and then in here we're going to be passing this guy that we have vectorized. Now this is in numerical form, so we're going to pass this guy in here. Okay, xtrain, there we go. Okay, so we feed the model to the data, we make predictions on the model, and then we're going to be using this prediction variable to test the accuracy of the model. So let's go back to setup.txt file. So this is what we're going to do. So check how many predictions match the actual labels. The actual labels is in the ytrain. Okay, so let's open it up. So accuracy, let's create a variable called accuracy, and we're going to assign it to accuracy score. The accuracy score is what we defined up here, which is this. We're going to check the metrics, the performance of the model, okay, and the accuracy of the model. So what we want, what we're going to pass in here is we're going to pass the ytrain, okay, which is the label, and then we're going to pass the predictions. The predictions carries the data that has been vectorized. Okay, so just save that in case you lose your work. Let's go back to the setup.txt file. So inside of the setup.txt file, so where we are right now, we've set up MLflow. We've trained the model using the training data, make predictions. We have not run this train.py file yet. We're still setting things up, okay? So the next thing what we want to do, we want to log metrics with MLflow, okay? We want to log these metrics. We want to log the matrix with MLflow, the model matrix with MLflow. So that's where MLflow comes in. Remember, we downloaded and installed it successfully. And then what we did here, we basically initialized the MLflow UI. It's a dashboard that's going to show you how the model is behaving, its metrics, its performance, so on and so forth. Okay, so let's go back. Let's go back to this terminal right here. Okay, I just want to do this. Let's go back to the setup.txt file. I want to log the matrix. Okay, so let me just copy this. Yes, we've done that. No, okay, no, this one, log matrix. Okay, log matrix with MLflow. So I'm gonna just copy this for the sake of time. We're gonna put a comment here. Okay, so the next thing we're gonna do, we're gonna log metrics with MLflow. So let's begin. MLflow log metric, accuracy. Okay, so what you are seeing, what we are doing here, what we are doing right here, you're gonna see this in the on MLflow UI. Okay, so the next thing we're gonna do, let's go back to setup.txt file. The next thing we're gonna do is we're gonna log the train model using MLflow sklearn log model. Okay, let's go back. We're gonna do just that. So MLflow sklearn log model. Okay, so in here, remember, we've got the model. So we're gonna log the model. We're gonna log the model, and then the next thing we're gonna do, go back to setup.txt file. We're gonna log the vectorizer as well. So the model and the vectorizer, we're gonna log them. Okay, so go back to VS Code, MLflow sklearn log model, and then in here we're gonna put the vectorizer in here. Okay, vectorizer, there we go. Okay, let's see, let's make sure that we got, okay, there's the vectorizer, and then there is the model. So the vectorizer is here, the model is here. So now both of which now are being logged with MLflow. So we'll see when now we begin to run this file right here, what we're gonna see in the MLflow UI. Okay, so let's go back to our setup.txt file. So this is our setup.txt file. So what we're gonna do, the next thing is we need to run our training script. Okay, we're gonna be running this command. Okay, so go back. Before we do that, actually, what I want to do is I just want to make sure that the stuff that we are doing, I'll just let's mark them as done. So I'll just mark the topics. Okay, done, such as this, done. We have not run it yet. Also, this is the next thing that we want to do now. Okay, so let's go back. Okay, so let's just go through this. Imports done. MLflow has been initialized using MLflow setup script. Loaded the data right here. Vectorize commands with vectorizer, we've done that. Assign the model to the variable. Start up MLflow and start to fit the model to the data, and then log the metrics of the model to MLflow. The another thing that I want to actually do here, let me just change this. Let me just name this variable train df just to keep the consistency with the previous session. Paste that, paste that. Okay, save. So you know, another thing that I want to do is I want to print out the data that has been vectorized. Let's do that. F string vectorized data, vectorized data. I'm curious. So xtrain, I want to print that. I want to see what it looks like. I'm just curious. Okay. I've been doing a couple of experiments with this so that I can give you the best quality content. So, but I actually want to print this out now that I'm here with you. I want to see what it will show us. Okay. Okay, but this will print it on the terminal. It's not going to be displaying that on MLflow UI. Okay. Okay. So what I actually want to do is I want to print this as well. Print. I'm gonna use f strings. This is the raw commands before. Okay, so yep, no xtrain. I'm just gonna call them xtrain. Bear with me. Okay, that's it. Okay, so I want to print these raw commands before they get vectorized, because here this is after they've been vectorized right here. Okay, actually let me put this up here. Let's take this off. Let's print it right. Let's put it here. Okay, so what we've done is we basically, this is the xtrain, this is the command, this is the commands column, and now I'm printing it before we vectorize it. This is the label, this is the label column, which has the values already, numerical data, and then right here this is after now we vectorize it. So I want to print it out and see what it looks like. Okay, so this is our model. This is the code that starts up MLflow. Okay, so what's the next thing that we want to do? Let's go back to our setup.txt file. The next thing that we're going to do is we need to run this guy. Okay, we need to run the train.py file. Okay, so let's go back. Let's clear the terminal. We want to run the train.py file. Okay. Okay, but you know what? Before we run this train.py file, let's just do more print statements here. Okay. Print. Let's use some f strings. Okay. Model accuracy. I just want to see the accuracy of this thing, which is what we want. We want to see how accurate it is. Accuracy. So basically what this means is that so this line of code right here that we just written, what it will do is it will give us the value and round it off to 2 decimal points. Okay, the next thing we want to do is we want to print this again. We want to print this, so we want to print that we've logged the model and the vectorizer to MLflow. Okay, model and vectorizer logged to MLflow. And then let's go back to the setup.txt file. So this is what we must do now. We have done this, by the way. This we've done. We've opened MLflow in a browser. So what I want to do is we want to run this thing. Let's run our train.py file. Okay. Okay, so let's clear this once more. So type Python. No, let's go deeper into the Threat Detector project folder. Threat Detector, clear. Python source train.py, hit enter. Okay, let's see. Let me just open this up a bit. Okay, so let's see what we got here. Okay, it's complaining. It's okay, let's see what the problem is. Threat detector source train.py in line 8. Let's go to line 8 and see. Okay, let's see from source. No, okay, you know what, let's just do this. This will be a long one. Threat, you know what, this is a, let me see, I know, let me just do this from MLflow. I don't think I need to put, no, there's no need for me to put source. We're already in source. Okay, so apologies on that. We're already in source. So we're already in source. Inside source, we've got MLflow setup.py file, and then we've got train.py. So what we want, we just want to import this function right here. Okay, let's clear that. Let's run this again. Okay, give it a second. Okay, so here we go. Okay, it says could not find experiment with ID. That, okay, we need to attach the ID of the experiment inside MLflow. Okay, so but before we do that, I just want to show you something here. Okay, so right here it says experiment with name threat detector does not exist, creating new experiment. So MLflow initialized. Let's see where we are. So inside MLflow.setup and MLflow setup, MLflow underscore setup, we've got MLflow initialized, which is this right here. And then the experiment name, let's see, threat detector. And then the URI, the tracking URI, it's localhost at port 5000. Okay, the next thing is let's go to train.py file, raw commands before we vectorize them. Okay, let's go. So the train.csv file, this is our data set which we split, which represents 80% of our data. This is the command column. It's got shutdown, echo, delete, rm, and so forth. Okay, let's go to the terminal and see what has been printed out. Okay, so we've got raw commands before this is before they were vectorized. We've got this guy right here, which is true, and then we've got echo, we've got delete, we've got rm. So these are in there. Okay, so you see right here it says command. This is basically the data that has basically been vectorized, right? Let's go back to train.py file. Let me just expand this a little bit. Okay, so this right here, vectorized data. Let's go up. Vectorized data. See, this says vectorized data, compress, sparse, row, sparse matrix of data type. It's integers. Okay, so basically what it did is it created a matrix. Okay, this matrix has, this is the data set of the matrix. So it converted. So what we've done is we've vectorized this data into this data. This is a matrix. Okay, we vectorize this data into this data. So this is the raw data. This is the vectorized version of the data. Okay, so okay, so the reason why we are seeing this problem right here, right, is because we may need to set our experiment explicitly. Okay, so the reason why we send this error, you see it says could not find experiment with ID, blah blah blah. You see these numbers right here. So when you go up, the first part of the code does execute, as you can see here. But the problem that we're having now is this guy right here. This one is giving us a problem. So the thing that we can do to try to resolve the problem actually is, I've seen when I was doing my previous experiments, is that when you don't explicitly set the name of the experiment, it can give you stale ID numbers. Okay, so let's do this. MLflow set experiment and give it the name and set the name of the experiment right here. Threat Detector. And let's save that. Okay, so let's clear that and run our code again. Let's see now. Okay, here we go. Let me see. Artifact path. Okay, here we go. Okay, this is better. Okay, so these are just warnings here, but so far we actually good here. We good. Woo! That's some good stuff right there. Model accuracy 75%. That's beautiful. Our model, the accuracy of our model, it's 75% on the training set. This is excellent. Okay, so we can actually go view our experiments right here. Let's copy this thing, follow the link, open this up. There we go. This is our model, man. This is our model right here. Model metric 75%. System, okay, we didn't add that. No traces recorded. Let's see artifacts. So this is our artifact. We've got requirements model. That's our model. That's our model artifact. That's our model right here. Okay, this right here is our model. This right here is what we're gonna serve as an API so that you can access it from anywhere on any cloud platform, so on and so forth. Okay, so that's our that's our YAML file for the model. Okay, this is good. This is excellent. So but what I just wanted to show you is this is what we've got now. So we've got we've created our model. That's the experiment. That is the ID, the experiment ID for a threat detector model. That's our run ID. Okay, so that right there, that's our source code. Okay, that's the accuracy of our model. Look at that thing. Okay, so model name Vectorizer, and this is our classification model to classify the commands that are benign from the commands that are malicious. Okay, and both the Vectorizer and the model, their accuracy is 75%. So this is excellent. This is some good stuff right here. So let's go back to our VS Code. So this is what we've done. We've initialized our MLflow, which is what we've done in MLflow setup. That was successful. The name of the experiment was printed out, which is Threat Detector. The tracking URI is there, which is localhost port 5000. So this right here is our raw data before it was vectorized. This is our data that is this is post vectorization, has been vectorized. And what you are seeing right here is we're seeing the accuracy of our model. Not only that, but we're also seeing that the model and the vectorizer has been logged to MLflow. So let's go to MLflow to see that. That's what you've got. If we go down there, so you see logged models too. So vectorizer and the model. So that's beautiful, man. Okay, let's go back to our setup.txt file. Let's see what we've done now. We've done all of this. Okay, this we've done. Let's mark it as done. This is done. Okay, and then also this is done. So we've checked the accuracy of the model. We've observed if the artifacts have been logged to MLflow. This has also been done. So basically what we've done is we've built our MLflow pipeline. Okay, we've built our MLOps pipeline. So the next thing that we're going to be doing, we look at setup.txt file. What we're gonna do in model 3.4, we will serve our model as an API. That's what we're gonna do. That's when I'm gonna start introducing things like Docker containers, so on and so forth. Okay. I'm happy with this. I'm happy with what we've done. Let me just do this again. Hit enter. Okay. Let's go back. Let's view the experiment. Yeah, this is that we ran. Okay, this was 20 seconds ago. Okay, let's open it up. And there we go. There you have it. There's the accuracy of our model. So basically what this gives you is that you can basically run multiple experiments to see the behavior of your model in terms of accuracy, what gets logged to MLflow. So if you go to overview here, you'll see this is what gets logged. You see log models, vectorizer model, model metrics. You can see that. System metrics. Okay, we haven't included that. The artifacts. This is our artifact. So okay, so I'm happy with what we've done. So you can run this multiple times, but the thing that I want to do is next we're gonna serve our model as an API. So this will be in module 3.4. Okay, so see you in the next lesson. Okay, hope you enjoyed what we've done this day. This was beautiful. Enjoyed the experiment as well. Enjoy writing the code with you. We hit some issues, but we fixed them, so we're good to go. So we are done with module 3.3. Okay, see you in the next lesson. Hope you enjoyed MLOps from scratch. Enjoyed it myself. See you in the next lesson. And with that, see you next time. Okay.